Hello, good afternoon.
Okay, Francis, we're live now.
Okay, is everybody ready? Or do you need any more time to?
We're ready, thank you.
Okay. So I will say good morning, good afternoon, good evening to everybody, depending upon where you live in the world. It's very good to see as many people as there are. I believe there may be more coming, but we will get started. This is a very complex topic, and let me get to where I really want to be. Where we're discussing cybersecurity. Any discussion of cybersecurity can be very, very complex. I will also recognize right from the beginning that even though this particular topic is narrowed down to OT versus IT cybersecurity for what I call or is called cyber physical systems, 1 hour is not going to be nearly enough to get to all the issues. I will also say that a number of questions were also submitted over the last couple of days. I've taken a chance of trying to discuss them directly, but even there's no way with 10 questions and many others that are based on that to really get anywhere more than superficially. But I'm hoping that at least I can point people into the right direction. So first, I'll just introduce myself. My name is Francis Cleveland. I work for Xanthus Consulting. I am the convener of the IEC TC57 Working Group 15, which is the cybersecurity for electric power systems. So probably some of my focus is going to be on that, but I recognize that there are plenty of other cyber physical systems than just power systems. So let's get started. I'm going to start with just some definitions. First of all, if you're going to have OT, which is operational technology, as opposed to IT, information technology, it's a little funny separation of the words, but what we're talking about is cybersecurity for cyber physical systems. So cyber physical systems can be seen as smart systems that include engineering that are interacting with networks of physical and computational components. It's not just computers, they're connected to real world devices, and these real world devices have impacts on the physical world. And the need to interact with these physical components from a time sensitivity, from an accuracy, all of that is extremely important. So we recognize that not only is there computation, which is the computer side, but we need absolutely communications to all of these physical systems, as well as controls. So this makes cyber physical systems quite different from just plain computers, which IT typically deals with. So as I said, I come mostly from the power system background. So just a short little thing here, a power system is a physical system, but it has overlaid on it an information infrastructure, which is a cyber system. And it's this combination that makes life difficult. In the past, the physical system, humans did everything. Now with the combination, with the addition of the cyber, an awful lot of the work is done by cyber systems. So I would also like to start with some of the key cybersecurity concepts. This is based on a paper that the IEC System Committee Smart Energy has developed. And it covers a lot of information, but what I'm going to cover here is sort of the 5 cybersecurity concepts. It's called for smart energy because this was the Smart Energy System Committee, but the same concepts are absolutely true for any other cyber physical system. So there are 5 key concepts. The first one is resilience. The idea is that it's not just security, but it's resilience. Resilience should be the overall strategy for ensuring business continuity. So it doesn't matter if something gets broken, which it will, whether it's a cyber attack or a failure, a storm, or a fire or whatever. There has to be a mechanism for recovering, coping with a situation when it occurs, knowing that it has occurred, and then working through it, responding to it, and after the incident has been resolved, to come back and start again, maybe fix things, maybe change your cyber response and your engineering response. The two go together. Remember, for cyber physical systems, engineering is equally important to the cyber side of things. Then security, concept number 2 is security by design. I won't get into that here because that's definitely a good approach, but not our topic today. Topic number 3 is, concept number 3 is IT and OT are similar but different. And I will also get into that in a lot more detail. But I just want to mention concept 4, which is risk assessment, really critical. You can't solve or prevent all problems. You have to take a risk assessment approach to it and figure out what is the most important and deal with it. And then concept number 5 is that there are cybersecurity standards and best practices. They exist. Maybe they're not complete. Maybe there are gaps in them, but these should be the security standards that are used as a basis for any cybersecurity work. This is really important, and the IEC is in the forefront with these cybersecurity standards. So just again, looking at IT versus OT, we'll get into a little bit more later on, but I think the one thing that I want to point out here is that typically, not 100%, typically IT focuses on preventing access to sensitive data. In the OT environment, it's mostly availability and integrity of the data, because you're trying to have safe and reliable operations rather than sensitive and private information protection. So that's one of the key differences. So what I'm going to do is at this point go through some of the questions that were raised, and I will take sort of a stab at each one of this sort of group of questions. And then after each one of these groups, I will sort of open the floor for questions to see who has some additional types of questions and discussions. I'm not the be all and end all of answers, so I'm hoping for discussions amongst you all to discuss some of the issues. It's not like I am the only expert, and I'm only one of many, many, many experts in this area. So I'm going to start with OT and IT concepts. And this is with response to a question that says, with respect to which aspects do you regard IT and OT security as familiar, closely related? And then the second is the opposite, with respect to which aspects do you regard IT and OT security as far apart? I'll get to these other questions later, so let's start just with this one. OT and IT concepts. As I mentioned, IT characteristics, a focus is on confidentiality and privacy. Human interactions with computer systems are the main drivers for security. So it's really that human interactions. Timing requirements are on a, quote, human scale, multiple seconds, minutes, hours. Cybersecurity technologies must reflect people issues using the public internet or private internets. But typically, they may be private in one sense, but they're not really. They're public systems. Another sort of main idea is that computers, since IT is not linked to any physical equipment, that's the concept here, computers can be turned off or applications stopped or deleted if problems arise. That's a key issue. The other thing is that the main impacts of a cyber breach are financial, reputational loss, obviously privacy problems, things like that. Whereas OT, the focus is on availability and data integrity. And the key here is that automation between computer systems is the main driver. Human interactions are usually constrained by well-tested applications within protected environments. And this stems from the fact that engineering has been such an important part of cyber physical systems. You've had to engineer these systems for safety, reliability. These systems don't change very often, unlike cell phones or even computers in the IT environment. These are ones that run, the systems run for years sometimes. The timing requirements can be milliseconds to seconds. So really often very, very stringent timing requirements. And the cybersecurity technologies must reflect automation issues for retrieving, validating, sending data in a timely manner not usually using the public internet, although that may change with distributed energy resources. This is one of the new areas that's going to be a real challenge for cybersecurity. And computers cannot be turned off if problems arise. This is just, you have to have them continue to operate in some form or another. So engineering is really, really important. This is absolutely one of the key elements. It's a combination of IT and engineering practices. And then the main impacts of a cyber breach are physical. Yes, there could be some loss of privacy or sensitive data, but most of the impact, the serious impacts, are safety related: loss of power, loss of industrial process, loss of medical procedures. Again, just covering a lot of this. So cryptography can be used by both IT and OT systems, and such as PKI, and both data at rest and data in transit need to be protected. Role-based access control is critical for both human and system access management. So cryptography is still quite valid for both worlds. It's the devil's that's in the details. And some of that is because authentication between systems requires different cryptographic processes than human-initiated authentication. There are problems that devices are not always available to reach back to their certificate authorities, unlike most IT environments. So they can't get to their revocation lists, and may use something like OCSP. Lots of end devices need to be treated as a group with group keys. Again, quite different from the IT world. Low time latency may require simpler cryptography. I don't mean from an algorithmic perspective, but simply not as much computational requirements. Authentication, for instance, but not confidentiality. And I think engineering plays a much larger role because of the physical devices. And the break the glass scenario is something that really can be quite important, because sometimes, the physical aspects of the system need you to be able to bypass some security measures, not everything, during emergencies. So one of the things I have definitely found is that the best solution is to make a team of both IT and OT experts and make sure they listen to each other. Okay, so what I will do here is stop and see if there are any questions. I believe the way we're going to handle this is either through the chat or raising your hand if you want to speak. Michael, are you in charge of that?
Yeah, indeed. And I have Troy Bellows, who would like to ask a question about...
Just one remark, but I don't want to take the floor now. It's Mr. Kovac joining from Switzerland. I'm joining through the phone, as Zoom is too insecure for our company. But that means that I will intervene last when everybody who raised his hand or her hand has spoken. Thank you.
Troy?
Hey, this is Troy Bellows from the United States of America. And I'm involved in switchgear and control gear components in the industrial side. And as cybersecurity considerations develop across the IEC standards, how do you see switchgear and control gear components and assemblies being impacted?
Okay, that's a very specific area. And what I will actually do is jump ahead. Oops, back here. The IEC TC 57 Working Group 15, which is the one I'm the convener of, has developed the 62351 security standards. These are the standards for switchgear, amongst others. But in particular, what we have is a series of standards. I don't really have time to go into all of them, but a series of standards that pick up on the different protocols that may be used for switchgear. So we're focused particularly on 61850, IEC 61850, but not exclusively. We are also using, able to protect a number of other types of devices. And let me just jump to here. This is, for instance, part 4, which has the application layer security profiles. It says MMS, but the reality is it's for any type of profile. And it provides a set of choices on how you want to, what degree of security that you need. So does this cover what you're looking for? Obviously, there's a lot of detail here, but these are the protocols, the 62351, that are actually to be used with switchgear.
Well, and we're starting to see some of the TCs developing focus groups or working groups to start to develop those standards. I was just curious on what your view is on the timing, especially being involved in the power generation side. What do you think the timing will be for manufacturers to adopt a number of these features in order to increase the level of security of their products and installations in the industrial space?
I would say that now is the time to start looking at this. I'll go back in a moment to another slide, but one of the things that has been a little frustrating, to be honest, is we've developed these protocols. We're testing them. We're developing the conformance tests for them. We've gotten a lot of evaluation of these, but we haven't seen much widespread implementation of them. And it's because there's still that sense that this is switchgear. It's in a safe environment, protected with locked doors or locked gates. Why do I need protection? So I think now is indeed the time to really start looking at these protocols. If you find something's missing with them, we're always in the process of amending them. So, we know that there always going to be changes, but we really feel that the key is to start using them and actually seeing where the problems might lie, where we need to do maybe something else as well.
I have a question from Fan Yi about, can you hear me?
Yes.
Question from Fan Yi about horizontal and vertical standards. Fan?
Yes. My question is, what is the IEC's effort in creating horizontal security standards for OT? Because there are so many different domains in there.
Okay, so let me first say that the ISO IEC are not the only groups to be developing cybersecurity standards, but they certainly are, the ISO in particular with the 27000 series and the IEC are particularly important in this process. So what I have here is a diagram that we've used in this cybersecurity standards and guidelines, where we've shown that we've got different areas of focus. So we have the sort of general IT security. And we know that that's important, but then we've gotten, and again, this is states energy systems, but it's really any type of OT environment where there are many standards that address cyber physical systems. So here's the sort of IT, here's the cyber physical systems, and down here are really the details of particular technologies. So here, these are more requirements. Here, they're actually technologies and possible solutions. So we also separated out the standards into the what standards, what you need to do, but not how to do it. So all of these standards here typically state what you need to do. So here in the 27000 series, it's more on the IT level until you get down to the more security for controls. You've got the 62443 series. Again, this cuts across many areas, but they're all for cyber physical type systems. And they are basically stating what you should do, not how to do it. And the same is down here. There's a number of very special technical documents that are focused on specific areas that say what. But then we have the how. And here are the internet standards that are very commonly used for how. Obviously, we've got PKI and a whole bunch of others, IPsec, TLS, SNMP, as well as I've mentioned before, the 62351 series. These are IEC standards. Again, these can cut across broadly, as can the 62443 from a what perspective. These standards can cut across from a how perspective. They can be implemented, for instance, network and system management using SNMP. It may be at the moment focused on the energy industry, particularly the electrical energy industry, but the concepts here can be expanded to any system that has a network. Role-based access control, this is a mechanism to do role-based access control. Then we have key management. All of these things are applicable to a large degree across different types of OT environments. And then we have this process towards compliance, which is critical for ensuring that you've actually gotten there. So this is what I like to point out. Yes, it's because of where it came from, this is mostly focused on smart energy, but the same things can be used in similar fashions across the board. One thing I would be very interested in is, are there specific areas where the 62351, which I said has been focused on switchgear, control systems, substations, now on distributed energy resources. We haven't really looked at medical devices. We haven't, and it's certainly true for industrial control, that's fine. But we haven't looked at things like medical devices, and we've even talked about trains and transportation and EVs, but there's still some areas where we may need to look more closely or work together with other groups to do that. So does that answer, well, address, I won't say answer your question.
Yes, thanks.
And we have a question from Gabriel Feverman. Are you there? Can you hear me, Gabriel? Or is that Gabriel Fiverman, perhaps? Not sure where you're from. I'll read out the question if Gabriel can't hear me.
Gabriele,
Perhaps he's left us,
or he's muted.
or he's muted. I can't see him. I'll read out the question. It says the reference on TC57 is mostly for protocols, as you mentioned, but what about the actual hardware, software standard development? And more to the previous question from the same person, where are you taking care of the vulnerabilities and patches?
Okay, that's sort of a broad question. We in TC57 are focused on the communications. So we're focused predominantly on the interactions between systems, so that we're not looking at the actual hardware itself and how to implement it in any specific hardware. So that's in this the 62351. However, in the IEC 62443, which again I call the what's, there are a lot of discussion of what you should be doing as you implement a particular set of cybersecurity measures into your devices. So what I would be interested in seeing is more effort being made, and this is an area that I feel the IEC has not yet really embraced, more efforts in making what are called use cases or case studies of how to actually use these standards, these cybersecurity standards in particular situations. Because I think that, yes, there's a tremendous amount of sets of requirements. You know, thou shalt have two-factor authentication. Thou shalt not let malware enter your system. Yeah, that's great. but how do you actually do it? What do you use from, say, the internet standards? Are there ones that you can use? Are there ones that are missing? Which of the 62351 and maybe other cybersecurity standards can be used? So it's still quite a wild west out there. And now with distributed energy resources, it's becoming even wilder. So it's quite a challenge.
And changing topic, we have a question from Jimmy Peng, who is with us, and that's about I believe, the resilience of metering systems. Jimmy?
Oh, yeah. Hi, I'm Jimmy from Singapore. And I think you listed my question in your slides, so I was waiting till then. I work in the system operation. So what I would just like to ask, how easy is it to really hack, let's say a PMU or RTU, or, let's say hacking your SCADA network? Working with industry, also with academic colleagues, it tends to be, I think, a human factor more than a physical or hardware or firmware issue. But I'd just like to hear this, your thought on this.
Right. Actually, it's you may be talking about metering and RTUs, but this is actually true of pretty much any devices out there. Yeah. There's no question that the human factor is still probably the leading reason for cyber problems, because of course humans have some interest, shall I say, in either disrupting things or gaining secrets or doing something nefarious. But there's also, on the other side, there's just simply software bugs, mistakes by well-intentioned people to do something. There are applications that don't run properly, that may mix things up. So there's a lot of reasons for trying to secure either meters or any kind of RTUs. But securing it doesn't mean it's not in the IT sense. And I think that's my main point here. It's not in protecting the information per se. It's really in making sure that the systems are resilient. They're resilient. And let me go to another diagram. Where did it go? Here. This is the key concept of resilience, where you need to know what you have out there, how to protect it. Most cybersecurity focuses on protection, but that's not the only thing. So if you have an RTU that's not functioning correctly, maybe it's a cyber attack by a nefarious person, but most likely it's some equipment failure or a communication, you know, the wires have been misconnected, or, you know, there's a whole bunch of reasons why something may not work properly. So you have to detect that problem and then find some way of responding or coping with the problem while it's going on before you're able to fix it or you know, get some kind of better way of doing it, and then recover. Again, I bring back the concept of engineering. Maybe there's redundancy, maybe there's redundant networks, maybe redundant RTUs if it's really critical. With meters, maybe there's a way of ensuring that, or checking to see if there's been some tampering, even if you know you're just reading it and it seems to be okay, but maybe there's evidence of tampering, so you'd have to get in there. Did somebody try to connect to the meter that shouldn't have been connecting to the meter? So all of this is the kind of approach that you need to take. It's not just protecting data, it's making it resilient, making your system resilient. And that to my mind is one of the key points. So I will point, in fact, to this NIST cybersecurity framework. This is a document. You can just download it from the internet, but it really goes into a great deal of, it's a what document, not a how. It's a what document, but it goes into a great deal of detail in an organized fashion where it does identify these different areas: identify, protect, detect, respond, and recover. I would seriously look at that because it's, again, really important to think of protecting cyber physical systems in an engineering perspective. Resilience, that's really the key here.
Probably, can I just probably rephrase what I understand what you, I totally agree, but there's one thing, and probably I have to say, you know, a general question, I think the general concept is usually what if there's an attack. So I was wondering, you know, is there physical, examples of hardware being attacked that you know, so when we talk about cybersecurity, we can move away from the what if and really go into this is what happened. And if we look at the recent one, and we look at a Ukrainian power grid, or you look at a Stuxnet, a lot of time really, that's what I was trying to point to, is that it goes back to the human factor. So you talk to utilities, they will just say, you know, well, we'll train our engineers, they will be, you know, more competent in dealing with their access of data and their security of the information. But I was wondering, are there examples that we can really refer to about devices actually being tampered? Yeah.
Well, there's, I guess the question comes back to the scope. Are you talking about such as the Ukrainian situation and Stuxnet, where there was definitely a human activity that had a real focus on wanting to destroy something? And that's obviously something that needs to be really reviewed. But most often, a cyber failure or a cyber event takes place because of a failure of some sort, a mistake, a failure, communications were dropped, things like that. And there are hundreds and hundreds, thousands of those types of examples. I will, this is actually not the engineering side, but here's one example was that for many years, power plants were being monitored by some entity, okay? Now the entity never changed anything. They never, issued a control or did anything to change anything, how the plant operated. But they did monitor the plant, many plants around the world for many years, until finally somebody noticed that they were being monitored. And then the systems were, all the plants, in fact, were reviewed to say, is somebody monitoring me? Is there a problem? But this lasted for years before somebody figured it out. Now, who knows what the entity wanted from this? But certainly it was not according to privacy or confidentiality that they should have been monitoring this. So it's the kind of thing that can happen. And so you need to look at it as saying, essentially, if you go back to the whole issue of risk, is this worth the risk? So risk management is really critical. Is this something where the possible impact, the probability of the impact, and the degree of damage from the impact, is that going to be worth trying to mitigate it? If you could say that I've got a meter on a residential house, and I've taken basic care, there's a password and it's different from meters to meter. So you can't use the same AAAA, which is what happened for a long time, as your password. If you take reasonable care, then maybe that's all you need to do. And you just say, well, maybe I will detect or, run some kind of program to detect whether there's any something funny going on. But I'm going to leave it at that. However, if there's something like, let's say you have a wind power plant, and you've been running it, and then all of a sudden some cyber attacker gets in there and causes all the wind turbines to continue to operate during a storm, during a high wind situation, which may damage all of the wind turbines. Instead of allowing them to shut down, which is what they do in very high wind. Okay, that's got a very high impact that may destroy a whole wind farm. So there you would should take a lot more effort to cover the possibility of such an event. So again, there are different ways of looking at it. It's not a single answer for us, for everyone. That's where you do have to do this risk assessment and then figure out what you need to do to take care of the key problems.
And if I could just add, I think you mentioned Stuxnet, and a lot of this malware, the Stuxnet worm included, are specifically designed to attack hardware. I think in the case of Stuxnet, if memory serves, it was specifically attacking motors in the centrifuges.
That's right.
So it's, human error leads to a computer or something being infected, and then the malware attacks the hardware or software,
Right.
as the
Well,
case may be.
yeah, so that's exactly the point. And if you look at the Ukrainian situation, the malware monitored what the SCADA systems were doing, so that it learned over time which commands to send that would say open breakers, because that's what they wanted to do. And then when they'd learned enough, they did that. They opened all the breakers. Well, that shouldn't have been a big problem, because then the operator could have just reclosed the breaker and everything would have been fine. But then they caused the SCADA system itself to turn into a brick. So it was just dead in the water. They could not use that SCADA system again. So that's where, well, in that case, they turned to the humans to actually close the breakers again. But yes, that affected hardware, in this case, the SCADA system itself. It just very smart way of turning a computer into something that can never operate again. They just have to throw it out.
That's right. We have a question that right at the beginning, a gentleman joined us on the phone from Switzerland.
That's correct. Thank you for giving me the floor. Stepan Kovac speaking here. So I work for my own company called IEC. It's actually a group now. And we are specialized in cybersecurity and data protection. And I'm very actively participating in the ITUT and ISO IEC as well. Actually, I represent SC27 in some ITUD group of cybersecurity experts. So the GCI weighted group, for those who may know about it. I heard your conference. It's very interesting. I didn't hear the first 5 minutes though, because of joining via phone. Most probably I wasn't allowed to hear the first minutes. But from what I heard, in general, I find it very interesting. I also find it good that you highlight the need for some horizontal standards, even if you don't name them with that name. And regarding the main entities involved into the cybersecurity space, I believe we should not forget about the ITUT, even if it has some issues, or at least had in the past, because actually it's the home of PKI. Well, you can say I'm preaching for my own church, so to speak. But that's not totally the case, as I have multiple hats. But I really believe we should give credit to, in particular, to Eric Anderson's group, who is editing PKI, and probably more interaction between the relevant actors of standardization of such matters, including the one I just mentioned, would be welcome. As, by the way, he's very much involved into the energy sector as well, being from the Danish Energy Agency. So yes, a call for more horizontality and more collaboration to achieve the best possible results. Thank you.
Yes, I absolutely agree. I believe that we still have a long way to go. It's and I will come back to the various standards here. And by the way, I will. The IEC will be able to send you these set of slides if for those that are interested. But I think we have certainly here a large number of very useful standards, but I think we still are missing, and that's maybe where gaps are, how best to use them for particular industries. So I think this is where different groups should get together. And one of the things that we do in the working group 15 is we try to work where possible, where agreed, where asked and where agreed, to work together with other groups in the IEC to come up with maybe specific sets of I call them use cases or case studies, where we say, for this particular environment, here's possibly what you need to do. Maybe here's what's not really available yet, or here's a better way of doing it. We've done this, of course, with a lot of utilities, as well as utilities, because again, we're more on the power side. But I could see reaching out across to different groups. And I think this is true of the 62443 group in TC65C, to try to make sure that all of the requirements, the OT type of requirements, are being addressed and understood. Because again, it's one thing to write a document, it's another thing to implement it. And I don't think we yet have the level of implementation widespread in the cyber physical world for actually knowing how well we're doing and where the problems may lie. And some of the problems may be as simple as how do you update certificates if you don't have any access to the internet? So there's a lot of these kinds of issues that still need to be better resolved. We have some solutions, but not really full-blown ones. So I see reaching out to different cyber physical environments is going to be really important to say, how do we use these standards, the what and the how.
I'd like to bring in John Coburn at this stage of TC13, who has a very interesting point about how we perceive critical infrastructure. John?
Yeah. Hi, Francis. I think we've met several times. Yes. Online with the Systems Committee. Yeah, right. So I chair the Standards Committee, or the Senelec Committee for smart meters. Yeah, and one issue that sort of comes up now and again on smart meters is the fact that they're fitted with switches. And traditionally, electricity meters, as has been mentioned before, sits on a wall, doesn't do very much. Meters, if someone hacks it, well, you might get someone fiddling the bill or whatever. In the UK, we have prepayment meters that have switches in them. About 20% of the population with a switch. But in common with quite a few other countries, we've gone smart meters where 100% of the meters will be fitted with switches. And I've had personal experience with issues where something has gone wrong, as Francis was saying. Some software, some firmware has done something perhaps it shouldn't have done. And lo and behold, the switches have gone off. Now, if you've got a proportion of the 20% that go off, then yeah, it's a bit of a problem, but it's not huge. But in the case of the UK, we've got 27 million of the things. And if someone does something so they all go off, and Stuxnet type thing, now you can't switch them back on. Now you're stuffed. You've got 27 million houses to visit to get the power back on. So it's not like attacking a substation where you've only got a few of those. This is where you're attacking millions, and it would be absolutely weeks of a job to fix. So in the Netherlands, for example, they recognise that as an issue. The simple solution doesn't cost anything. Take the switch out. Problem solved. They worked out that I think it was over 45% of the system cost was to do with trying to secure it. So and it's much the same in the UK. And they've just the security for the meters is just absolutely unbelievable. And when you've done all that, it comes down to a microprocessor firing a port, hitting a switch, clonk. And if it decides to do that, there's not a lot you can do about it. So what appears to be not a very big problem could be a very big problem.
Yeah, there was actually a book written about that.
Yeah, Blackout.
A novel.
Blackout by Mark Ellsberg. He's absolutely
Right.
When I read that, I thought he knows exactly what he's talking about.
Right.
He
And
actually told you how to do it.
yeah,
More or less.
it's indeed, I think this is you talk about meters. I talk about distributed energy resources. Again, we're talking about equipment that's at customer sites, not in a factory, not in a control center, not even in a substation. So it's spread out to locations where it's much more difficult to manage the cybersecurity. There are not many cybersecurity experts living in houses. So this is, in fact, one of the areas that I think needs to be looked at more. Yes, we may have a technical solution to it. I'm not sure it's what I would even call an engineering solution. You say, well, just take out the switch, but yeah, but then you lose a lot of capabilities that you might need. So it's a short-term solution, but not a long-term solution if you actually end up doing that. So I think this is where we really, again, need to take a look at use cases. We can even use that the book as a use case. But then see what it is that we would need to do to maybe not prevent the problem from happening, but at least ameliorate it, have some way of coping with it. You know, this is what we need to really work through and say, okay, you know, if X number of switches go out because of some malware, first of all, how could we have stopped the malware that's from arriving in the first place? But secondly, how do we isolate it so that it doesn't spread, kind of like the coronavirus, spread everywhere? You know, so we have a lot of issues that I think, again, would be well worthwhile looking at from a perspective of how best to use what security standards and technologies we have, and how they might work for particular environments. One of the environments, in fact, I'm working with right now is the DER environment, distributed energy resources. And developing cybersecurity requirements or best practices for that. But this all needs a lot more effort.
The last one of these I had, I thought I was going around the loop again a couple of years ago. Same deal, meters going off, couldn't switch them back on. It was actually mechanical. It was actually the switch.
Huh.
Got overloaded and blew open and wouldn't shut.
Yeah, this is
that really caught me out. I thought,
it's not necessarily, you know, the horrible cyber hacker. It's just equipment failures, all sorts of things.
I wonder if we could squeeze in one last question, because I see that we're coming up to the end of the hour, and it's from Giovanni Cabronero in Mexico, that's had his hand up for quite a long time, actually.
Yes, I think I did see that.
Giovanni?
Thank you very much. Talking about the implementation path for all these standards, what would you recommend to start with the general standards, the 62443, and then dive into the 62351, or what would be the best approach to implement these standards?
Well, I would say that the key is, what are you trying to provide security for? Again, if we look at the key concepts of resilience and risk assessment and some of these other things, you need to sort of zone in and say, what is it that I'm trying to secure? Is it a control center? Is it a substation? Is it a meter? You know, is it a hospital? You know, so then what you could do is go to the 62443, or I mentioned, oops, let me just, here's the 27,000. Here's the 62443 series. You could take a look at those and see which ones seem to make most sense. I know in the power industry, we're very focused on 62443-3-3 as providing very basic cybersecurity requirements. I would also say that if I go here again, the NIST cybersecurity framework, what I found is that what's covered in here is very similar to what's in 62443 in terms of what requirements. And so I would even go to this document, and with a focus on this area. The document covers a lot of other things too, but focus on this area. And then there are what are called crosswalks, where the requirements from this document then are identify what items in, let's say, the 62443 series is the same or quite similar. And that's an area that I think is really important to take a look at. So I would go to the 62443, and I would also go to this cybersecurity, NIST cybersecurity framework. I think that's probably where the best start for that is, once you've identified what it is you want to secure, because they're all different.
And the secure communication would be the 62351.
You're talking about the 62351
communication, the devices.
Yes, these would be good for. They're focused on communication standards. Okay, so this is the security for communication standards. So these are the how you would secure your communications. So if a communications is what you're looking for security, this would be how you would do it. The 62443 here is what you need to do. You know, you should have two-factor authentication, as I said. You should have some way of ensuring that the certificates are up to date. You should make sure that the supply chain is secure. There's sort of what you need to look at, but not how to do it. I hope that helps. It's a huge, huge topic. So, you know.
Yeah, but thank you very much.
Okay.
And I think that would be a lovely place to end. Francis, I don't know if you've got some final words you'd like to say.
I think only that, as I started off saying, this is a very complex area, cybersecurity. It's also very new. It's also expanding very rapidly, and not just in new cryptography algorithms. That's one area, but more on how to apply it, particularly to these cyber physical systems. This is where the real challenge is, because everything is new. It's hard, you know, particularly with new systems. Everybody says, I just want to get this new system to work. I'll add cybersecurity on later. And so we end up essentially with no cybersecurity, or something sort of vaguely bolted on, you know, some kind of password, username and password, which often isn't adequate. So I really feel that we need to have experts from various fields, from various areas, come together with some cybersecurity experts to say, you know, how best could I do this? What really needs to be done? What more standards might need to be developed, but at least identify what needs to be done and take a look at what exists out there, see what can be used and what might need to be updated. So I thank you all for listening and asking questions. This is, again, a huge topic area. So I know not everything was, was answered by any means, but I am open to people sending me emails, asking questions, or obviously asking each other questions, because I think that's, that's important as well.
And I just add a big thank you to Francis for taking us through this very difficult area. And I'd also like to add that although the session is ending now, the conversation is continuing on Facebook. We will try to answer, hopefully with Francis's help, all the questions that are asked. And we'll also post a video of this session to YouTube, and we'll send you all the links. Thank you all very much.
Okay, thank you, everybody.